these two lines that we see here are what's called parallel, meaning that they're in the same plane and they extend forever and they never cross. Well, there's certain angle relationships we need to know here, some that we've dealt with in the past. First off, all of our vertical angles, such as 2 and 3, they're across from each other. 5 and 8 are also vertical. And remembering from before, anytime we have vertical angles, they will always be the exact same size. Then we have our linear pairs, which are right next to each other, angles 1 and 2. Since you have a straight line here, these two angles would add up to 180 degrees. Angles 2 and 4 here would also add up to 180 degrees. Then you have the relationship between angles 1 through 4 and angles 5 through 8 at the bottom. First off, the ones that correspond. 2, which is on the top right side of our top line here, corresponds with angle 6. And we find out here that corresponding angles will also always be congruent. So 2 and 6 correspond. 5 would correspond with 1. 7 would correspond with 3. 8 would correspond with 4, and so on and so forth. So those are what we refer to as corresponding angles. Then we have alternate interior angles. First off, what we need to know is what interior versus exterior is. When you're talking about the parallel lines, the ones that are the angles that are between the parallel lines are known as interior angles. The ones on the outside of the parallel lines are known as exterior angles. And then we have alternate versus same side. The angles that are on the same side, let's erase that. The angles that are on the same side of the transversals, those are obviously called same side angles. And then you have what we know as alternate angles. Alternate means there's one on one side of the transversal and one on the other side. So that's where we get the terms. That's where we get the term alternate interior, alternate exterior, and all this. So anytime we're dealing with alternate interior angles, these will always be congruent as well. So alternate interior are the ones on the interior, and they're on opposite sides. So here, 4 and 5 and 3 and 6 would be alternate interior angles, and they will be the same size. Then we have what's known as alternate exterior, which would be like angle 7 and 2. They're on the outside, and they're on alternate sides. Angles 1 and 8 would also be alternate exterior, and these will be the same side as well. Then we have same side interior, which would be like 6 and 4. They're on the same side of the transversal, and they're on the interior. Same side interior angles will also be supplementary. They'll add up to 180. 5 and 3 would also be same side interior. Then you have finally same side exterior. Same side exterior angles will be on the outside and on the same side of the transversal, such as 1 and 7 or 2 and 8. These are also supplementary angles. So actually, if we have the measure of one angle, let's say that, well, we'll just do the first example here. If the measure of angle 1 is 120 degrees, then we know that angle 4 is vertical with it, so it'd have to be the same. The ones that correspond with them at the bottom, which is angles 5 and 8, would also be 120 degrees. And then the other angles actually have a measurement of 60 degrees because, again, you have the straight line, so they have to add up to 180. You have vertical angles, and then those same exact two angles on the bottom side will be the exact same side. And notice here, alternate interior angles are the same. Alternate exterior angles are the same. Same side interior angles add up to 180. Same side exterior angles also add up to 180. And we'll be using this principle anytime we're talking about any figure that has parallel lines located inside of it, such as here. It says the measure of angle A is 97 degrees. Well, if we'd like to, these parallel lines we could extend further so we can see it a little bit better. And here would our transversal be that cuts through it. And we see now that this angle and this angle down here would actually be same side interior angles, so we know that they add up to 180. Then we could say, well, these are also parallel. Well, that these are also parallel. And that these two angles right here would also be same side interior angles. So we know that that would also equal an 83-degree angles. And you can see then, by extending that further, that you've actually got the opposite angles in a parallelogram being the same size. We could also extend this fact to, if we had a triangle to where these two lines are parallel, then this angle and this angle would be corresponding angles. Because again, if we drew those on a little bit further and drew that down, we can see now that Those would be same side, it'd be corresponding angles. These two angles here would also be corresponding angles. We see that this angle and this angle would be same side interior angle, so they would add up to 180, and also this angle and this angle would be same side interior and add up to 180. We see the same thing in a trapezoid, to where if we've got all these parallel lines, the corresponding angles, these would be the exact same size. These two angles would be the exact same size, and we see the same thing here with same side interior angles, that those two angles would add up to 180, and so would this angle with this angle. And it could extend even further up the top. This angle here would correspond with this angle and be the same size, and the same thing on the other side.